simple calorimeter. It is also known as coffee cup. It is used to measure heat released in non-combustion reaction such as heat of neutralization and heat of solution. Heat released by the reaction, Q reaction, is absorbed by the solution, we call it Q solution, and the calorimeter. So same as the bomb calorimeter, we have water and Q calorimeter, but here your solution might not be water. It is solution, it can be other than water, so Q solution and the Q calorimeter. So here is the equation. Heat released by the reaction is equal to negative, here negative means heat is released, Q solution, heat absorbed by the solution, plus Q calorimeter, heat absorbed by the calorimeter. So the Q solution formula is mass of solution times specific heat capacity of solution. This is small letter c. Small letter c means specific heat capacity of the solution times the temperature change plus heat absorbed by the calorimeter. The formula is heat capacity of calorimeter times the temperature change. So the basic principle in simple calorimeter, this is the formula. Q reaction equals to negative Q solution plus Q calorimeter. And here Ms is the mass of solution, Cs is the specific heat capacity of the solution, delta T is the temperature change, capital letter C here is the heat capacity of the calorimeter, and temperature change. However, some books ignore the heat loss to the calorimeter itself. For this case, you just calculate the Q solution. If the heat capacity of the calorimeter is not mentioned, you just use the equation Q reaction equals to negative Q solution. You don't need to take account the Q calorimeter, plus Q calorimeter, because if you plus Q calorimeter, you need to get the value of heat capacity. So if in the question, the value of heat capacity of calorimeter is not mentioned, just use equation Q reaction equals to negative Q solution. Example, a quantity of 100 ml of 0.5 molar HCl is mixed with 100 ml of 0.5 molar sodium hydroxide. So this is the neutralization reaction. In coffee cup calorimeter that has a heat capacity of 335 joule per degree Celsius. So this is the capital letter C, heat capacity of calorimeter. The initial temperature of HCl and NaOH solution is the same, 22.5 degrees Celsius, and the temperature of mixed solution is 24.9 degrees Celsius. Can calculate the temperature change and then calculate the heat of neutralization reaction. Heat of neutralization definition means you need to calculate for 1 mole. So that's why here in kilojoule per mole. If the question doesn't state it must be in kilojoule per mole, you have to know that you need to calculate for 1 mole, because the definition of heat of neutralization is for 1 mole of water produced when you react acid and base. That's the definition of heat of neutralization itself. We need to produce 1 mole of water. If the question doesn't ask here in kilojoule per mole, you must write in kilojoule per mole, because you need to understand that heat of neutralization you need to calculate for 1 mole. Next, assume the density and specific heat capacity of the solution as the same of water. So here we have volume of acid 100 ml, mass of acid 100 ml. We need the mass of the solution, so we have to convert the volume into mass volume of HCl into mass of HCl. So we times by 1 gram per mil. So the HCl mass will be 100 gram. Same goes for sodium hydroxide. You have to convert into gram. Will be 100 gram. So mass of solution is the mass of HCl plus mass of NaOH. So the total mass of solution will be 200 gram. Because we want to substitute into the Q solution. Q solution, we need the mass of solution, we need the specific heat capacity of solution. So we assume the specific heat capacity solution is the same for water. So just substitute here mass 200 gram, and then for specific heat capacity water 4.18. If the mass here in kilogram, you have to change to gram because the specific heat capacity per gram. So if the mass in kilogram, you have to change it to gram first before you substitute into this formula. And then the temperature change 2.4 degrees Celsius plus heat capacity of the calorimeter 355 joule per degree Celsius given in the question, and times the temperature change, and you will get the heat released in the reaction is equal to negative 2810 joule. So this is the heat released. This negative shows the heat is released. This is not for 1 mole. This is for 200 gram. 200 gram, how many mole? So you have to look at here first, neutralization reaction. Neutralization reaction, you have 0.5 mole per liter. The molarity is given in the question. If you notice here, the molarity is given 0.5 molar HCl, 0.5 molar sodium hydroxide. So the molarity is given, volume is given, you can calculate the mole. Molarity times the volume, the HCl number of mole is 0.05 mole, and the NaOH is also 0.05 because the molarity is the same, the volume is also the same. So both number of moles are the same. So when 0.05 mole HCl, 0.05 mole of sodium hydroxide, neither is in excess. So here 0.05 reacts with 0.05, we will get 0.05 sodium chloride and 0.05 mole of water, because here 1 mole, 1 mole, 1 mole, 1 mole, if 0.05, all 0.05, because the stoichiometry for all of them are the same, so the number of mole will be the same. And then when 0.05 mole water is formed, because you know the heat of neutralization definition is the 1 mole water produced by neutralization of acid and base. So you have to focus on the number of mole of water. That's why we compare in this chemical equation. We want to look how many number of mole of water produced, because the heat of neutralization definition to produce 1 mole of water. So here it is 0.05 mole. So we focus on water. When 0.05 mole water, heat release negative 2810 joule. If 1 mole of water, the heat release is cross multiply, you will get negative 56200 joule for 1 mole. So 56200 joule per mole, or 56.2 kilojoule per mole, because delta H neutralization, heat of neutralization, the definition itself is for 1 mole of water produced. So that's why you have to calculate for 1 mole of water. Don't leave it 0.05 mole. That's not heat of neutralization yet. You must calculate for 1 mole. Next example, to solution 100 ml acid, given the molarity 1 molar, 100 ml 1 molar sodium hydroxide, both same temperature 21.1 degrees Celsius, added a styrofoam cup or coffee cup calorimeter and allowed to react. So here we know that this is neutralization reaction. We have acid reacts with base and water will produce an salt. The temperature rises to 27.8 degrees Celsius. So from here you can calculate the temperature change. Determine the heat of neutralization expressed per mole of H2O form. Means you need to calculate for 1 mole water form. Here, the heat capacity of the calorimeter is not given. So your equation is only Q reaction equal to negative Q solution. Now, we have to change the volume into mass first, times by 1 gram per ml, and you will get both 100 gram. So the total of the mixed solution is equal to 200 gram. Use the equation Q reaction equals negative Q solution. Don't plus Q calorimeter because you don't have the information of heat capacity of calorimeter. So just use this equation. Q reaction equals to negative Q solution. Mass of the solution 200 grams. Specific heat capacity assume same as water. And the temperature change 6.7 degrees Celsius. You'll get the heat release 5601 joule. This is not for 1 mole yet. This is for 0.1 mole of HCl and 0.1 mole of sodium hydroxide. To get this number of mole, take the molarity given in the question times the volume and you'll get the number of mole. And then put that information into the chemical equation. 0.1 mole reacts with 0.1 mole. Since this is 1 mole for each, 1 mole HCl, 1 mole sodium hydroxide, 1 mole sodium chloride, 1 mole water. So all, if you compare stoichiometry, all of them are 0.1 mole. The actual number of mole, 0.1 mole. So this amount of heat released by the reaction is for 0.1 mole. The question asks you for 1 mole of water. Since this is for 0.1 mole water, compare 0.1 mole water releases 5601 joule. If 1 mole cross multiply, you will get 56010 joule per mole. Delta H of neutralization equals to negative 56.1 kilojoule per mole. This is the answer for heat of neutralization, delta H neutralization.